Today we're going to be talking about completing the square. And if you're in my Algebra 2 class, you would be in section 4.6, part 1. So 4.6, part 1. And as we've learned, you cannot always factor quadratic equations, but I was very hesitant in saying that didn't mean that there was no solution. As we've been learning the last couple weeks, there are several ways to solve a quadratic equation. So today we're going to be learning about another way called completing the square. So to solve an equation by completing the square, you must transform one side of the equation into a perfect square trinomial. And this is where me talking about those perfect square trinomials is going to be really helpful if you remember the rules. Okay, so how can we tell if something's a perfect square trinomial? Well, x squared plus 16x plus 64 is a perfect square trinomial. I call it a PST because the first and the last terms are perfect squares. So let's look at that. The first term is a perfect square and the last term is a perfect square. And that last term is positive. It's got to be positive. And the middle term, so this guy, the 16x, is the product of the square roots of the outer terms of the first and last term. So I see that x squared, its square root is x. 64, its square root is 8. That 16 is double them. Okay, so that's going to be important for this section. So we also need to be able to create perfect square trinomials. In order to complete the square, we're going to have to be good at this skill. All right, so first we're going to make a perfect square trinomial, and then we're going to rewrite it as the square of a binomial. All right, so if I want to complete the square, the first thing I'll be doing is I'll be taking this middle term, this 8, I will cut the number in half. Okay, so half of 8 is 4, and then I will square it. So 4 squared would give me 16. Now, I have just created a PST, a perfect square trinomial. In factored form, as the square of a binomial, it will be the square root of the first term, the sine of the middle term, and the square root of the last term, quantity squared. All right, let's try that again. I take half of 10, negative 10. Half of negative 10 is negative 5. I square that. I'm going to get a positive 25. I've just created a perfect square trinomial, and then writing it as a square of a binomial would be the square root of x squared, which is x, the sine of the middle term, which is negative, and the square of the last term, which would be the square root of 25, which is 5. All right, let's try again. X squared minus 16, I'm sorry, minus 6. Okay, you guys have 6 on your screen. Sorry, I wrote 16. X squared minus 6x plus, we take half of 6, we square it, we get 9, so plus 9. Writing it as the square of a binomial. All right, we get x, the sine in the middle term, which is negative, and the square root of 9, which is 3. Quantity squared. All right. Now, you might have noticed those were pretty easy because the middle term was even. When it's odd, we still can do it, but I'm going to show you a quick trick. Don't work with decimals, always work with fractions. So if I want to take half of 3, that means divide it by 2. So that's 3 divided by 2. And then if I square that, I get 9 over 4. So this becomes 9 over 4. All right, to write that as the square of a binomial, I take the square root of the first term, the sine of the middle term, and the square root of 9/4, which would be 3 halves. All right, and I quantity square it. Try another one. I take half of 7, which means 7 divided by 2, so 7 halves. I square it, and I get 49 over 4. So plus 49 over 4. All right, then we write x, the sine of the middle term, and then the square root of the last term, which would again be 7 over 2. Quantity squared. You might notice that it's always working out to be whatever half the term was, half the middle term was. All right, So based on the above, when do you think it is best to complete the square? Well, I'm hoping you're saying these guys were not fun to do. And so usually we're really only going to want to complete the square if the middle term is even. The middle term is even. Otherwise, you're going to go to a different method. So let's review those methods again. We can factor. Factor is the easiest one. We're always going to try and factor if possible. Then we move on to the square root method. We would use that if there's no linear term, so no term that just has a plain old x in it. And then complete the square. I do that a lot if the middle term is even. All right, so now we got to get good at a couple of other skills. Another concept, I've missed a page. Another concept that we have to be good at if we want to complete the square, and actually let me add a page here, is solving by taking the square root. So we practiced this before break, but we're going to do it again. So let's practice. So if I want to solve this equation by using the square root method, the first thing I have to do is get rid of that 2. So he's being multiplied, so I'm going to divide both sides by 2. So I get 2x minus 1 quantity squared equals 4. All right, now it's square root ready. I have a perfect square equaling a number, so I can take the square root of both sides, and I get 2x minus 1 equals, now here's the part we got to remember, plus or minus 2. Remember, when we take the square root of both sides, we have to do plus or minus. All right, so then we add 1 because we're solving for x. We always put it in front. So I have 2x equals 1 plus 2, which is 3. And then I have 2x equals 1 minus 2, which is negative 1. I divide by 2, so x equals 3 halves. And I divide by 2, so x equals negative 1 half. Okay, if we can be good at both of those two skills, then we can complete the square just fine. You might be able to tell I have a little cold. All right, so now let's solve by completing the square. Now it's just a process. We're going to be doing the 2 things I just taught you, coupled with a few other, okay? All right, so let's do that first. First, we're going to make sure we set y equal to 0 if it isn't already. So remember, we always have set y equal to 0. Then we want to make sure the coefficient in front of x squared is 1, okay? If it's not, I'm going to explain what you to do in another lesson. But for now, we're going to make sure it's 1. All right. Then we're going to get it complete the square ready. To get it complete the square ready, we need to add 2 to both sides. We bring the constant to the other side. This is the constant term, so I add it to the other side. And then I leave room next to the 8x. Okay? All right. Just like that. Then I do what I taught you to do by creating a perfect square trinomial. So I take half of 8, which is 4, and I square it, which gives me 16. Now, here's the big thing. Whatever I do to this side of the equation, I have to do to the other. So I have to add 16 on the other side. So this is important. I'm making the left a perfect square trinomial, but I have to add that 16 on both sides. Okay, then I write the left side as the square of a binomial. So I write this as x minus 4 quantity squared equals 18. All right, then I solve by taking the square root of both sides. So I take the square root of both sides, and I get x minus 4 equals. All right, 18, we learned to simplify. This can be simplified into 9 and 2, so it's going to be plus or minus 3 root 2. Then I add the 4 to solve for x, and I put it in front. So my answers are 4 plus 3 root 2 and 4 minus 3 root 2. Okay, I'm giving you some time to catch up. All right, let's try one. together. Okay? X squared. Sorry about that, guys. Okay, sorry about that. So we, the first thing we do is set y equal to 0 if it isn't already. And I'm going to put the 0, I always put the 0 on the right side. So I'm going to do x squared plus 6x minus 8 equals 0. All right. Then I get it complete the square ready after checking to make sure my coefficient is 1. So I'm going to add 8 to both sides. And I get x squared plus 6x, leave room, equals 8. Now I turn the left side into a perfect square trinomial. So I take half of 6, which is 3, and I square it, which is 9, and I add it to make a perfect square trinomial. But whatever I do to one side, I don't want to forget to do to the other side. All right, then I turn the left side into the square of a binomial. I take that perfect square trinomial, and in factored form, it gives me x plus 3 squared equals 17. All right, now I take the square root of both sides, and I get x plus 3, x plus 3 equals plus or minus root 17. Then I subtract 3 and I put it in front. So I'm going to get x equals, it's going to go over here, negative 3 plus root 17 and negative 3 minus root 17. Now, as a reminder, it would say solve for x. The directions would say solve for x, find the zeros. It could say find the x-intercepts of the graph. Or it could say find the solutions. So you got to be really cognizant of what you're doing. So this is the third method for solving a quadratic. And again, it's called completing the square. Okay? All right. So what I would like you to do is I'd like you to try number 1 and 2. And remember, when you do that, I want you to get them complete the square ready first. So go ahead and try those. Okay? And I will check your answers tomorrow in class, okay? Okay, now, when you're done with that, we're going to do one more thing. We can also use the concept of completing the square to put an equation in vertex form for graphing. So remember, let's recall that vertex form is when it's in this form, y equals a, x minus h squared plus k, where hk is your vertex, okay? To do this, it's very similar to completing the square, except I don't set it equal to 0. I leave the y in the equation. All right, so here's an example. Y equals x squared minus 8x plus 11. I'm going to subtract 11 to the other side. So I get y minus 11 equals x squared minus 8x. All right, now I take half of 8 and I square it, which gives me a positive 16, but I also need to add it to that 11 on the other side. So I have now y plus 5 equals the x squared minus 8x plus 16. That's the perfect square trinomial. I'm going to write it as the square of a binomial. So x minus 4 squared. Remember, square root of the first term, square root of the last term, sine of the middle term. And then I'm going to subtract 5 to the other side and put it in the back. And now I have a quadratic equation in vertex form. So my vertex is 4, negative 5. All right, and we're going to practice that one tomorrow in class, but I just wanted you to see it. The only difference is instead of setting y equal to 0, I leave it there. But I follow the exact same process of completing the square. All right, guys, I'll see you tomorrow. Bye.